Okay, hello. Alrighty, well, thank you all for coming to this session. Just quick poll, how many people were actually at the workshop, the hands-on workshop? I'm so happy you came back, yeah. After what happened yesterday. No, so today we're gonna take a deeper dive into Kubernetes. Just quick show of hands, how many people here have heard about Kubernetes? Everyone, yeah? How many people have used it? Yeah, okay. And seen in action, like seen Kubernetes in action, seen somebody demo it. Okay, so not as many people. Okay, so what I'm going to do is just a very, very high-level introduction to Kubernetes before I jump into the more advanced use cases of it. So my name is Ray. I'm a developer advocate for the Google Cloud Platform. And that is my profile picture. And the reason why I'm always behind the camera is because I'm kind of shy. And the other reason is because, well, sometimes when I get really, like, if I don't feel so good, you'll never know if this is actually this person, right? Yeah. So, but I had more hair back then. That's the only thing that's to take away from the slide. If you want to reach me on the internet, just find me on Twitter @Satanism. I've been a Java developer for many, many years, and after that was enterprise architect. And aside from technology, I love to travel. This is actually me traveling in Northern Asia, hiking in the desert somewhere with a compass because I had to find an oasis, apparently. Somebody told me I can find an oasis in the middle of the desert that I can actually stay for free for one night. So, yeah, so I actually had to hike about 4 hours to find this desert. It was really, really hard. Throughout the process, it's like, it's so hard, like I'm taking a step in and then have to take a step out, and whenever you take a step into the sand, you sink a little bit. Okay, how many people actually hiked in the desert before? Oh my goodness! Wow, so many. What were you thinking? Yeah, but the problem is that when you hike in the desert is really hard. It actually reminds me of writing a J2EE application back in the day. That was literally what was going into my mind at the time. But anyways, this talk is going to be about autoscaling your application, and I happen to write an autoscaler. But keep in mind, this was the very, very first time I have ever written an autoscaler before. I have never done this before. So if anyone has written an autoscaler before, you probably know a lot more than I do already. And just a very, very high-level introduction. We're going to be using Kubernetes. And many people heard about it. I'm going to show some of these in action. But just in case, Kubernetes is an open source project that's been open sourced by Google. And now there are many, many contributors. And what it does is to manage your containers for you across the clusters, right? I think that in the demo, I'm going to show a little bit about this. And the beauty about Kubernetes is that it can actually run in multiple environments, whether it's in the cloud, whether it's Google Cloud or somebody else's cloud, or in your bare metal on-premise systems as well. In fact, I actually run a Kubernetes cluster on my Raspberry Pis. You can actually do that. Yeah. So what are we going to scale today? That's the topic of the talk today. I'm going to scale this thing called Infinispan. How many people heard about Infinispan? Yay! All right. How many people are using it? What? well, but you heard about it before. That's great. But it's a distributed caching system, and there are other ones out there like Hazelcast and quite a few other ones. But I like Infinispan because, well, I'm actually ex-Red Hat, ex-JBoss. I used to work a lot around this thing as well. So what it is a distributed memory cache. It's a NoSQL key value store. Everything is stored in memory, optionally on the disk. But why I want to scale this is because it actually has a really nice and wonderful elastic property. What do I mean by that? Well, first, it is distributed cache, right? If one of your JVM is running out of heap, you can just add another into it. So I can run a cluster of this caching system with like multiple nodes. And in each one of these nodes is going to be able to store a bunch of data. Right? In this case, we have 3 nodes, and the data is actually spread across multiple nodes. And you can also specify how many copies of that data you want across all the nodes, just in case one of the nodes fails, you can still have the backup copy somewhere else, and the system is smart enough to make another copy for you. All right? And this is nice because you're fault tolerant based on the number of copies that you have. If you have 2 copies, then at most you can have 1 node that fails. You have 3 copies, then you can have 2 nodes that fails, and such and such. So if one of the nodes fails, then it's going to redistribute the data for you to the other nodes that's still alive. If you're running out of space, If you're running out of space on all of the nodes, what you can do is to just add another node, and then it will automatically rebalance all the data entry for you, right? And what is also really nice, do I have this slide? No. What is also really nice is that in this type of system, the client actually knows exactly which of these servers to go to fetch the data. If you're looking for data entry A with the key, it will actually know exactly which one of the node has that entry. It's actually being done by consistent hashing, so based on the key, it can determine which node to connect to, so that you don't have to go through one node and then go to extra hops to other nodes. But that also poses some challenges in terms of how you can use this in Kubernetes, which I'll kind of show you how. Okay, so about a year ago, when Kubernetes 1.0 was kind of in the works and stuff like that, I was using Kubernetes and I thought, hey, it would be really nice if we have Autoscaler, because in Kubernetes, you can scale out the number of instances of the application for you very, very easily. And I thought, what if I can do this automatically? That would be kind of nice. But at the time, there was no Autoscaler built into Kubernetes. So I actually wrote this talk about a year ago. I developed all the code a year ago. And that's what I'm going to show you. But today, Kubernetes actually has an Autoscaler that you can actually use. But I use this talk to show you how you can actually use the API instead and build something interesting with Kubernetes. So with autoscaling, keep in mind, I have also never done autoscaling before, just to make sure everybody understands. This is the very first time I've done this in the past year. And remember that Kubernetes actually has a real autoscaler built in now, and it can autoscale based on CPU utilization, like how much CPU the application is using. It can also do custom metrics now, metrics that's specific to your application, but that is still kind of in alpha stage at the moment. Okay, so what we're going to scale is in Infinispan, but what is really easy to scale today is if you were to scale out by increasing the number of instances, that's really easy to do, on a stateless workload, a workload that doesn't have any state, on workloads that has no data, right? Like if you have like a service that doesn't store any data, you can scale as much as you want, out as much as you want, as many instances as you want. And what is also really easy in many of these systems is to be able to scale based on system metrics. And by system metrics, I mean CPU utilization, or in some cases, memory utilization. What is more difficult is to scale a stateful application in general. That's really hard to do. And also to be able to scale in, right? Because when you scale out, you just need to add more instances. When you scale in, you have to figure out, are you going to lose any connections? Are you going to lose any data? Is it expensive to be scaling out? Is it more expensive to scale in? And what is usually not built in with the tools is the custom metrics. Because in Java world, at least in my mind, in addition to CPUs, you also want to get specific metrics from, say, GMX. Right? There are many, many metrics that are exposed via GMX or exposed via RESTful endpoints. And those are the metrics that I care about, and that is exactly the metrics I want to use for my Infinispan scaling. So today, in the next 30 minutes or so, I'm going to just do the difficult stuff, which is to be able to autoscale Infinispan, which is a stateful workload, based on the number of entries in each of the nodes, because based on the number of entries, I can know how much utilization the node has, right? Because in Infinispan, it's never CPU bound. It's always a hash lookup, so it's really fast in terms of CPU utilization, but you do have a space constraint based on the number of entries. And we're going to be doing this both scaling out by increasing the number of instances and scale in by reducing the number of instances, and we'll see some challenges there. And again, I don't know anything about autoscaling. I didn't know anything about it. So I did a lot of research into the general pattern. And this is the pattern that I kind of studied on and come up with. Well, basically, first of all, there is the actual node at the actual instance that you want to run, that you have running. So you can have one instance of this or multiple instances of these. And every one of these instances should be pushing some kind of metrics into a metrics server. And there are some open source projects for it. But I actually wrote my own. And the metric server is supposed to store the metric data, like a time series data somewhere, so that you can actually go back and say, how much utilization am I using in the past 2 minutes or past 10 minutes? Because that is the data I'm going to use to determine whether I need to scale out or scale in. The autoscaler is the component that will check this metrics and make that decision. So if right now I have 2 instances, and based on the utilization, I'm way over the threshold, then I need to tell somebody to scale this out by adding another instance or by adding like 10 other instances, right? So the autoscaler will make that decision. And once it makes the decision, it will have to tell somebody to actually do the work. And that component is generally called an actuator. So autoscaler decides I need 4 instances now. The actuator is the person or the component that's responsible to scale this based on the number that you need. And the actuator will then take a template, what your application should look like, and then instantiate it into a real instance of that application. Okay? That's generally how all of the autoscaler that I studied works. It's basically all of these basic components in there. So since we're going to be doing this in Kubernetes, Kubernetes is actually a really good system to fill up some of these boxes. One of the things that you can do with Kubernetes is to scale the number of instances of applications that you want to use. And it's called the Replication Controller. And you can tell the Replication Controller how many instances you want your application to run. And that essentially is an actuator. If I tell Kubernetes I need 2 instances, Kubernetes will make sure that there are only 2 instances running. And the way that you describe your application is by using your container images, right? The container image has exactly what you need to run the application. It's like a template for it. And then you have the pod definitions. In Kubernetes, we have these definitions, these descriptor files that will then tell you how to instantiate a pod, how to start your application. So Kubernetes will take that information and then actually start the actual instance of the pod. And then what I had to do on my end is to just write, at the time when there's no autoscaler, I had to write my own. So I wrote my own autoscaler, I wrote my own metric server, and I wrote my own metric store. And that's what I'm going to show today. So again, keep in mind I've never done this before. This is my first time. Yeah. So the way that you can actually use Kubernetes to scale in and out, well, typically you use the API, you use the command line. Okay, I'm going to show you some demos right now. So to show you what this looks like, I'm going to use a visualizer. This is a visualizer I have used for a while now. It's a really good look into, say, a caching system in this case. And this little red dot that's floating around, that's actually a single node of Infinispan node. Okay? And what I'm going to do is to just add some data into it. So what I'm going to do is get into a shell that has the client library that I need to use. Okay. So I'm going to get into this client library. I'll tell you what this actually does in a second. And then I'm going to go into app. I'm going to do a Java jar, run the client library. I'm going to add 100 entries into this node. And the server is called Infinispan. Okay. And I actually slowed down, I actually delayed each entry add just so you can actually see the bubbles coming out, right? Because otherwise it would just be done in like a second. So it's there for the visual effects. So now we have 100 entries in this system. And if I were to scale this, so all I have to do is say kubectl. I can do scale RC, the Infinispan controller. And then I can say how many instances of this I need. I'm going to say I need 2. And what is going to happen now is that Kubernetes received this message. And in the cluster that the Kubernetes is managing, which I have, I think, 5 different machines right now, it's going to find one of the machines that has enough capacity to run this additional instance of Infinispan node for me. And very soon enough, you'll see that another node just came up. And it's actually running on different machines, potentially. If I do a get pods wide, you should be able to see that, whoa, this is a little bit too hard to see. There we go. So I have the controller here that's running on this machine, which ends in TPLA, and another node that's ending on WSKH. So they are running on different machines. If I were to start another node, all I have to do is to say, replicas is equal to 3. Okay? And that's going to do that as well. Now, notice that there's, even though I added 100 entries, and I have 2 nodes, there are actually 200 entries in total now. Why? Because my copies, the number of copies I have is 2. So if I have 100 entries, it's going to make 2 copies. Then I have 200 entries in total. They're just redundancy. If I bring up another node, 200 entries divided by 3, that's about 66 entries each. And that's exactly what the system has done for me. Yeah, pretty good. And check this out. If I were to kill one node, that is fine. If I were to kill 2 of these instances, if I scale directly back down to 1, what is going to happen is it's actually going to lose some entries, right? Because if you kill 2 of the 3 nodes at once, you're losing data, which is not something you want to do when you're doing autoscaling. And when you're scaling in, you do not want to lose data like that, okay? So that's one thing to keep in mind. Scaling out could be easy, but scaling in could be a little harder. Okay. And it's going to take a little time for it to shut down gracefully, so we'll wait for that. Now, how do I actually do this? This is all done via the command line, right? That just goes 1. And I only have 67 entries left, which is not good. But I'm doing everything via the command line right now. But one thing that's really, really nice about Kubernetes that most people don't know about is that all these command lines, they get translated into actual API calls. And Kubernetes actually exposes all of the functionalities directly via the API. So for example, right now I have a secure proxy that's being opened. I'm using kubectl proxy command to open a secure proxy into my cluster of machines. And via this proxy, I can access the API securely directly through my local laptop. So here I can actually do, let me do this very quickly. I can show localhost 8080 and API/v1. That will get me to the Kubernetes API. And from here, I can say, OK, tell me how many pods, which pods are running. So all I have to do is to change the URL. And then you can see the actual pods and pod definition directly via the API. And this is all outputted as a JSON format, right? So you can really easily convert that into your languages and your objects that you need to work with. And because I'm interested in Replication Controller, I can go ahead and find the Replication Controller. And you can also do a label selector. You can actually search in Kubernetes to figure out which replication controller you want to find, which ones are interesting for you. So here I can say, label selector, the name label is equal to, I'm going to say Infinispan controller. Maybe that's, no, there's nothing there. So maybe Infinispan, there we go. So now I can actually see all the replication controllers that has such a label, right? Which is really, really nice to use. And once you find this item, you can actually dig into the actual details. So it's just a REST API, right? So you can drill down into the specific replication controller that you want to look at. So what you can do then is I'm going to copy and paste this URL and just go straight into that replication controller. And here I can actually see all the information, all the details about this replication controller. But that is just reading. So what I can see right now is that I can read that the number of instances right now, yeah, I know what replicas means. The number of instances right now is just 1. But since this is a JSON API, a RESTful API, you can also do the post and the put operation as well to modify the system. Okay, so this is where it gets really, really interesting. So rather than just having 1 instance running, if I want to use the API to tell it to run 2 instances, this is what I do. So I can, for example, come back here, get out of here. I'm going to use curl, and I'm going to grab the JSON, right? And I can save that into a file, like that. And if I go into the file, this is like the current state of the system as of this moment. I can actually change that number to 2, or whatever number I want. You can change other things as well. And then you can save that, and then you can just post it back, or in this case, we're going to do a put. So this is a little long command, but it's curl put. The content type is JSON. I'm reading it from the file I just wrote. And let's see what happens. So just so you know, right now I have just 1 pod running, 1 instance of my application, which is this one. And as soon as I put this command, if I go back here, there we go. You can see that a second instance is being started. And once it's ready, we should be able to see this directly on the command in the visualization tool. Come on, kind of, yeah. So what I have also added in here is a health check. So this doesn't show up until the health check actually passes. Okay. Now that is really cool. That's awesome. But now I have 2 instances running now. And remember when I was adding my let me see here. When I was trying to add the number of entries, this is the command line I used. I'll show you this again. I did Java jar. Okay, the number of entries. Let's say 200 now. And S is actually the server I want to connect to. Now here, because I have 2 instances of Infinispan running right now, they actually both have a unique IP address, right? They each have a unique IP address. But when I'm trying to connect to it, all I give was this thing, Infinispan. All I gave was the DNS entry, okay? And the reason I'm able to do that is because I actually created a service in Kubernetes. And the service, at the most simplest terms, is that it's like a load balancer. It creates a load balance IP address that helps you to route the traffic to the different instances of the application that you have. And it's smart enough to do that as you scale in and scale out of your application. But with Infinispan, it's going to be different. Why? Because remember, the client is actually smart enough to figure out which node it should be connecting to. It doesn't need a load balancer. It's load balanced on the client side. So in this type of use cases, having a single load balanced IP address doesn't really work, because you can actually, if you are using Infinispan and you connect to one of the nodes through the load balancer, but that load balancer doesn't have the data that you want, what's going to happen is it's going to make another hop. It doesn't work that way. It's actually not efficient. So what I have created in Kubernetes, actually this is a concept that very, very few people know about, it's a headless service. A headless service has no IP address as a load balancer. A headless service basically creates a DNS entry that has multiple IP addresses in it. And then when you're connecting to, say you're trying to resolve Infinispan as a host name, it's going to round robin and figure out it could be going to any one of these nodes. But that's fine, because once you connect, the client will then retrieve a topology of the entire system that you have running, and it will be smart enough to make that decision. Okay. So just to show you what that means, if I were to ping Infinispan, there we go. Did I? Yeah, Infinispan. There we go. So that's ping 10.12.04. If I ping enough time, it will be different. But there's another one, get entry, I think, hosts Infinispan. There we go. So this, I don't have dig installed, so I'm using a command line that just shows you the DNS entries. So here you can actually see that I have 2 different IP addresses that gets resolved by the DNS entry. And that is called a headless service. It has no stable IP address, but you can use DNS to figure out all the nodes in the cluster. The other way you can do it, and this is actually how we cluster them together to join them together into a cluster, is via the API, of course. So I can actually go here and say, I want to see all of the pods that's running with a label selector of the name Infinispan. There we go. And here I can actually see all of the pods that has this description. And within here, I can also see the IP address as well. So here I can see the pod IP address. So for every instance of my pod, I can use the API to figure out the IP addresses. And this is really, really nice, especially when you need to cluster things together. Whether you're using Infinispan, Hazelcats, JBoss, Wildfly, whatever, they all need some kind of discovery mechanisms to figure out all of the nodes that's up and running. Okay. Now that's all really good. We have one more issue. The issue is that if I were to try to access this API directly from within the pods, directly from within the application, running inside of Kubernetes, it's going to fail the way I have just done it. So if I were to do curl HTTPS, and then the endpoint DNS name, which again is created by Kubernetes, and if I were to say I want to see all of the pods, if I do this, it's going to fail. Why? For obvious reasons. Number one, it requires a CA certificate. And as Java developers, I think we all love CA certificates, yeah? I don't. So luckily, part of Kubernetes, it has a concept of secrets, right? So the secret for example, for the CA cert, it's actually mounted directly inside the pod that every pod that has the right access can get to. And that is stored here in var run. Can you see it? So it's in var run, secrets, of course, Kubernetes, and service account. And here you can see there are 2 files or 3 files here. There's a CA cert, and then there's a token. So what I can do then is to use the CA cert. There we go. So I can do CA cert. I think just one is ca.crt. Wait, is that not right? Is it 2? Yeah, 2. Let me try again. There we go. Cool. So now I can actually use the right certificate to authenticate this connection. But I still have another problem, which is that this is unauthorized. For me to get to the API, I have to be able to identify myself with some kind of authentication, not just the cert, which is just for SSL, but I need to identify myself with a token or username or password or something. With a service account that's built into Kubernetes, you can actually get the access token that you are supposed to be using to get access to the API. So the token is actually right here. If I show you what the token looks like, that's what the tokens look like. And what you need to do is to put this token inside of the header as part of the request to the Kubernetes API server. And I can do that very easily. I can do a H, and I think it's authorization, bear, and then I need to input the token in here. So that's just a short way for me to include the token as part of the header. And if I do that, then everything works. Yeah. So now you can actually use your application with the right credentials and the right certificate to access the API, which is really nice. And the way I've done it, my autoscaler actually is written in Groovy. and so what I'm doing, yeah, did I hear some? Yeah, thank you. Oh, of course, Guillem is here. Yeah, it was all written in Groovy, and I'm very, very proud to say that. And so what I have to do is to create like a SSL socket factory, a dedicated one, that actually knows how to get the CA cert and make sure that's part of the keys, so that when you make the connection, it actually connects. And then I'm also using Spring and Spring Boot. So what I'm doing with all the clients is that I'm using a REST template, which uses the SSL factory, and it always adds this authorization token into it. And so every time I'm trying to make a RESTful call to my Kubernetes API server, it has all the right credentials and all the right CA certs. Now, if you don't want to do this yourself, there's actually a really, really nice client library called Fabric 8. Fabric 8 is another JBoss project, and they actually created a very nice client library that you can use so that within your application, your Java application, you can very, very easily get access to the API server as well. Okay. And like I said, for all of these nodes that's clustered together, I'm using the API for my service discovery as well. So that when one Infinispan node starts, behind the scenes, it's actually using JGroups. Okay? Just like every other JBoss project, it uses JGroups to discover other nodes that's in the system. Now, by default, JGroup uses multicast. How many people here are able to use multicast in their data center? In your data center, yes, that's right. Probably not. Most likely not. But you know, in a cloud-native system like this, you also don't want to specify the static IP addresses either, right? Because static IPs just don't work in this kind of system because the IP addresses can come and go. When you scale in, when you scale out, you just don't know which IP is going to be there. So there's actually an open source JGroups plugin that can discover all the JGroups node directly by using the Kubernetes API. Okay? So that ties up the loop very, very nicely. Yeah. All right. So let me show you a few more other things. How is that with the Spring and Groovy work together? So it's very, very easy. I'm using Groovy, so I'm just writing an application. And then I got all these annotations on the top, right? Basically, I really just need to enable two things that's really important in this type of jobs, is that it's got to be async, and I needed some scheduling. Why do I need scheduling? Because my autoscaler has to wake up every once in a while to check against the metrics that's there. And so I'm using the scheduling annotation to do that. So let me see if I can find it. There we go, scheduled. So I can schedule this thing to wake up every once in a while and decide on how many nodes to scale to, and it goes. And also I'm using async because the scaling operation itself doesn't have to be synchronous. It just can be a synchronous operation. I'm also using SLF4j. I don't know if anyone's using this. Anyone? Yeah, quite a few. And then there's an annotation for that too. Also works with Groovy, so that you can just get the log object every single time, which is really nice. So you don't have to do like logger equal to new logger factory to create, whatever. No, you don't need to do that anymore. Just use the annotation. It's really nice. Okay, so another thing that I need to show you a little bit about is how am I collecting the metrics, right? So right now, I have 2 of these nodes running, and I can actually see that they have 67 entries each. That's actually collected via GMX. But my metric server only receives RESTful payloads. I only receive JSON payloads, right? So I needed something that converts from my GMX endpoint that pushes the metrics out into my RESTful metric server in this case. So what I've done, I found this other project online. It's called GMX Trans. I don't know if anyone's using this, but it can basically periodically wake up and then pull the GMX information from your application and then push it out via a number of different methods. And I wrote a custom one just for my autoscaler, right? Just for my metric server. So you can do that. One thing that many people ask about is the concept of pods in Kubernetes, okay? Every one of these instances is running inside of a pod. And whenever I do a kubectl get, I'm trying to get a pod. Not a container, but a pod. And I explained this a little bit in my other talks, but I'll just talk about this a little bit here again, is that a pod is really a closely related, tightly coupled set of containers that have to live and die together, that they have to share the same resources, all right? And again, the bad example of this is to run your front-end, back-end, and MySQL containers all in the same pod. That is a bad use case. Why? Because then you cannot scale them out independently from each other, and they shouldn't be living and dying together. Your front-end could die, your back-end can die, but they should not be dying together like that. So this is actually a common use case. What I'm doing here right now is that in my Infinispan pod, I'm actually running 2 different containers. One container is actually the Infinispan server itself. The second container is actually the metrics collector. The second container is actually the GMX trans collector. So that they're both living in the same namespace, and my Infinispan server is here, my GMX trans collector is here, and they can just talk to each other, and then everything live and die together. That's beautiful. And that's why in this console here, you can see 2 rather than just 1. All right. So let me show you how this works. This autoscaler works. Yeah, no, that's my talk. I don't have any demos. Nothing actually works. No, just kidding. So what I'm going to do is I'm going to get my service IP address from my autoscaler. And I'm going to post a new definition into here. It's a create autoscaler. And I can show you a little bit here. So this is what this is going to do is to just make a post request into my autoscaler application that I wrote. And what this is going to do is to say, OK, I need to autoscale my Infinispan controller. And I don't want more than 100 entries on each one of the nodes, because that's my max. That's what I can handle. And I'm going to do this check every 10 seconds. And at minimum, I should have 2 instances, and at maximum, I should have 10. Because at the minimum, I need 2 because I need high redundancy, right? I need high availability. And maximum, I need 10 because that's all the things my system can handle. So what I can do then is to create this autoscaler. And there you go. But I have no load on the system. Everything's under 100 right now. So I'm going to generate some more load. And if I were to look at the logs as well, get pods. Here we go. I'm going to look at the logs. So you can do kubectl logs f and the name of the pod. And here I can actually see what the autoscaler is doing. And right now, it's just pulling the data every once in a while. Okay. Now, I'm going to create some new node. So I'm going to go to app and Java jar, the server, 100 entries. Let's just say 150 entries or something like that. And server is Infinispan. Now, think about this. How many servers should this have to handle 100 entries each? 150 times 2, because redundancy, that's 300 entries. Divided up by 100, that should be 3 nodes, right? So let's see if my autoscaler does it. So I'm going to add the entries right now. So you can see this scaling up slowly. And I should have 150 on each node. And if I go back to my autoscaler, it's going to be able to pull the current average. And here we go. It just saw that the value was 150. And very soon enough, hopefully, there we go, it's going to tell the autoscaler, tell Kubernetes to scale out. And I think it just did. So if I were to check, oh, not here. Not that one either. Let me do this one. Yeah, there you go. kubectl get pods. There you go. You can actually see a third node is being started. And there we go. It just joined the node. And now it's averaged out kind of nicely. And I can do this again if I want to. I can take this up to, say, 500. And by definition, 500 by 2, that's 1,000, right? And then 100 entries each, that will be 10 instances, right? And as I'm doing this, it will just get increased, and my autoscaler is going to pick up the metrics from the metrics server, and it's going to actually decide to spin up more than one instance, potentially. It might actually decide to spin up like 5 other instances at the same time. Okay, there we go. So another node just joined. And if I see get pods, there you go. Some are dying and some is joining. Yeah, pretty cool. But this will kind of equalize out until it reaches about 10 nodes. So let's see if this is actually doing that. So if I get pods again, there we go. More and more are being started. Yeah, you can see all the listing up there. They're still being started because the starting may take some time. And there you go. It just, oh, boom, like everything is here now. and the data will be redistributed as well. And you should get about approximately 100 entries on each of the nodes. Yeah, pretty cool. Now, what it will be difficult to do is to scale in. Now, I'll show you what I mean by that. So if I were to remove some entries, so for example, right now I have 1,000 entries in total, but it's really 500 distinct entries. If I were to remove 400 of them, I'm going to use the operation remove, okay? And that is going to take away the entries from my system altogether from all of the nodes. You can see some of them decreasing already. Now, what is supposed to happen? I had 500 entries, unique entries. I'm decreasing by 400, so actually only have 100 left, right? If the autoscaler is not smart enough to handle this, it's going to say, oh, I have 10 nodes. Now I need to scale back to 2 nodes only. And if that happens, it's going to take away 8 nodes at the same time, and you're going to lose data. You don't want to do that. You don't want to do that. So what I have in my custom autoscaler, the reason I like it is because I can customize the rules on how I want to scale in. And in this case, I'm going to be scaling in only 1 node at a time. Okay? So I think you already saw 1 node goes away, and in about another 10 seconds or so, it's going to take another node and another node and another node. So every time I'm taking away a node, the system will then rebalance the data to the other nodes, and then you take away another one, rebalance, and take away another one, and you rebalance again. All right? So one last thing is really, really important when you are dealing with autoscaling, actually 2 things. One is about the noise, okay? When you are spinning up a new instance of something, especially if you're dealing with the CPU, the spinning up of the application will most likely to be like 100% CPU. And that will introduce noise to your metrics overall. Because as you are scaling out, wait a second, I should be reducing my average utilization. It actually increases it because the spinning up itself is going to cause a peak in terms of how much CPU you're actually using. So you gotta be really, really careful with that. And most of the things I have studied so far is to avoid noise is really just to space out the timing between the scale out and scale in operations. You need to give it some kind of grace period so that you can let the noise to even out itself over a longer period of time. If you do this very, very quickly, then the noise is going to cause havoc in your autoscaler. You don't want that to happen. The other thing that you have to watch out for is what if an instance goes away? When an instance goes away, the metrics that's associated with that instance don't matter anymore, right? 10 seconds ago, I may have 5 instances, and they have 100 entries each. If one of the instances go away, that 100 entry on that one instance is no longer applicable. Like, I don't want that in my metrics anymore. So let me show you a little illustration of that. So let me see here. So here we have node 1 and node 2. They have 150 each. And if node 1 goes away, I need to go ahead and remove all the data that's associated with node 1 for my average utilization, because otherwise I'm counting for something that's not there anymore. So I have to remove that data, right? And the way I can do that, which is really nice again in Kubernetes, is that you can actually watch for events. And this is really, really powerful. Rather than pulling for events every single time to see what is the state of my system right now, what you can do is, all right, I don't know what happened here, but I'm going to do a clear. There we go. What you can do is, for example, here we go. So I can do a get pods, and then can do a -w. That means watch. When you're watching for something, when an event happens, you'll actually get streamed directly into your console, right? But you can also do the same thing via the API. So here I have the API. I'm like selecting all the pods that has the name of Infinispan. What I can do is then I can do a curl with the same URL, and I just say watch is equal to true. Now, all of a sudden, the ampersand doesn't work. Yeah, let me try that again. Now, all of a sudden now, rather than closing the connection, this is actually streaming all the events that's happening to the pods that I care about. So then you can monitor what is going on in the system in almost near real time. And so whenever I receive an event that says a pod has been removed or an instance of the application has been removed, I will go ahead and remove the metrics. And that's how I'm doing. That's exactly how I'm doing this in my autoscaler as well. Yeah, and all of these things are actually on GitHub as well. So if you go to my GitHub /Satanism, which is my Twitter handle as well, you can find my project 8R. It actually stands for autoscaler because there are 8 characters between the A and the R. And that's the way for you to find this the project. And check out Kubernetes as well, because it really makes some of these tasks really, really easy and simple to use. So that's all I have to demonstrate today. So thank you very much. And there's like a minute left, so are there any questions? Yeah? Question? You mentioned there is an autoscaler now in Kubernetes. That's right, yeah. Do you have the same functionality? Yeah, so the autoscaler in Kubernetes, the one that's more mature is the horizontal pod autoscaler using the CPU utilization, right? So what I can do is, for example, let me get out here, get RC. So if I want to autoscale my Infinispan controller with the Kubernetes autoscaler, all I have to do is do kubectl autoscale, RC like that, and I can give it a min, maybe 2, and the max is 10. And then I can say CPU %, I think it's like 20, 30. That's how you set up an autoscaler directly inside of Kubernetes. So in that case, you are facing data loss? Yeah, so in this case, it's purely based on CPU utilization. In 1.2, there's also the alpha feature, which allows you to expose custom metrics as well. But since it is in alpha, I haven't really advertised it so much, but you should try it. The way it works is that rather than pushing the data into a metrics server, the way it works is that Kubernetes will pull the data from your pods, from your application. And it has to pull it from a very, very specific data format. And that data format is called the Prometheus data format. Okay? So it is not any format that you want to use. You have to use that specific data format. Right? And then you configure in your descriptors on how and where to pull that metrics, and Kubernetes will then start pulling it for you. And then it can auto-scale based on the custom metrics. Yeah? Good question. Yeah? Anything else? No? All right. Well, thank you all very much.